Hello, welcome to today's video where we're going to be looking at how to do algebra division. Because we can do division with numbers, of course. Can you do it with algebra too? Well, yes, and long division is one method of doing that. I'm saying that very specifically because there is another way you can do algebra division, or at least one other way, and one of the other ways is called the grid method for algebra division. I do have a separate video showing you how to do that method as well. You only need to know one of these two methods, I should say. So it's ultimately a case of seeing which of the two you prefer to do and then just sticking with that method. They both do the same things, they're just presenting it in a different way. So, therefore, focusing today on algebra division, algebra long division, I should say. We're going to start off by focusing on the skill. How do you actually do the method itself? And then we're going to be focusing on how that looks in the context of a wider question, because ultimately, I'll be honest, you're never going to get asked in an exam to do a question that looks like the question you can see on the screen right now. But anyway, this is just to get a head around what the method is. So, how do you do the method? Well, you start off by writing the thing that's being divided. So I'm going to write x squared plus 6x plus 8. Then do a weird curvy thing next to it, to the left, and then you do a straight line along the top. And then to the left of the curvy bit, you write the thing you're dividing by, which is in this case x plus 5. And then algebra division works on this idea of a repeated process. And each repeated process is a very similar idea. All you've got to do is look at the highest power thing that's in the thing that's being divided. Look at the highest power thing in the thing that you're dividing by, and then do those things divided by each other. So x squared divided by x. X squared divided by x is just x. So you then write the result of that up top. Then what you've got to do is you then got to do the thing you just obtained, in this case an x, and you've got to multiply that by the thing you were dividing by. So I'm now going to do x times by x plus 5. So x times by x plus 5 would be x squared plus 5x. Then what you've got to do is you've got to basically take that away from the line above. So I'm going to do x squared plus 6x plus 8, take away x squared plus 5x. So, carrying that out, x squared take away x squared is no x squared, 0 x squareds. You're expecting that You're expecting that to happen because if this method goes well, the first thing that you've got left should always cancel out. And the 6x take away 5x will then leave me with just positive 1x. And then we've got 8 take away, well, no other constants, so the plus 8 is just going to carry forward, really. And then we've just got to repeat that process from the beginning again. Look at the highest power thing here in the thing we've got left, highest power thing in the thing we're dividing by. Divide them by each other, so x divided by x is positive 1. So we add 1 on the top, and then we do positive 1 times by x plus 5, which is x plus 5. And then we are going to subtract that away from the line above. So therefore x take away x, again we're expecting that to cancel, and it does. And then we're doing 8 take away 5, which is 3. Now at this stage, I know I'm done. The reason you know you're done is the last iteration of the repeated process is when you reach that constant term on the top. So once you get to the point where you're writing things that don't involve algebra on the top, that's when you know you're about to be done. You then just finish off that repeated process, whatever one you're on, and then once you've finished that one, you know you're done. How to interpret your answer though? Well, basically the stuff you have on the top is what we call the quotient. That's, in other words, a posh way of saying what's the part that divided nicely? What's the part that divided to get a whole thing, if you will? A bit weird to talk about whole things and stuff because we're talking about algebra, but that is still the idea. And then the thing you have at the bottom, after you've completed the method, if you do have anything left over down there, that is what we call the remainder. That's the bit that didn't divide nicely, the awkward bit that's left over. Okay, that's the general idea of the method. Now applying that more quickly, just to give you an overview of it, putting it all together, and also showing you how to apply it to a slightly longer algebra expression, also looks a bit more complicated. Ultimately, the method doesn't become any different when you're doing it to this style of question. It just means you've got to do more repetitions of that idea. So we're going to write 2x cubed minus 9x squared plus 13x minus 6, weird curvy bit, straight line, and then write x minus 2. Highest power thing here, highest power thing here. 2x cubed divided by x is 2x squared. And then 2x squared times by x minus 2 would be 2x cubed from doing 2x squared times by x, and 2x squared times by minus 2 will get me minus 4x squared. And then we're subtracting that from the line above. Doing the subtraction of, again, the 2x cubed are cancelling out. I was expecting that. Minus 9 minus minus 4, lots of x squared, will get me minus 9 plus 4, which would be minus 5x squared. And then I've still got that 13x there. I've still got that minus 6. Repeating the process again, minus 5x squared divided by x is minus 5x. Minus 5x times by x minus 2 would be minus 5x squared, and positive 10x. And then we're going to subtract that stuff away from the line above. So therefore the 5x squared, the minus 5x squared will cancel out, and 13x take away 10x is 3x, and then the minus 6 carries forward. Then 3x divided by x is positive 3. Now I've reached the constant term on the top. That immediately is telling me that I'm already on my last repetition of the method. So therefore, now finishing it off, 3 times by x minus 2 is 3x, and 3 times by minus 2 is the minus 6. And then I'm going to subtract that away, and 3x take away 3x is 0. Minus 6 minus minus 6 is minus 6 plus 6, which is 0. So interestingly, this time there is a remainder of 0. The quotient is still the thing that's on the top. So we had a bigger quotient this time. That's because we had to do more repetitions. But then the remainder, interestingly, was 0. What that is telling you, if you get a remainder of 0, is the thing you were dividing by divided into the expression nicely. Okay, well, I did tell you that you are unlikely, practically guaranteed, to not get asked a question in the wording that we saw before. Algebra division is just a tool to help you do other things in the context of a bigger question. So I'm now going to show you a couple of examples of what that would look like. One of the first things they could do is they could do something that looks like what you can see on the screen right now. We've got a function, and then we're given that x minus 2 is a factor. Because we've been given it, we can just use that fact to our advantage. It's not a question where you have to show that it's a factor. If you're ever asked to show that something's a factor, you shouldn't be using algebra division. You should be using something called factor theorem, which will be covered in another video if it hasn't already. But therefore, because we know x minus 2 is a factor of f of x, that means it's something we can divide by. So therefore, what you've got to do is algebra division. Do 2x cubed minus 9x squared plus 13x minus 6 divided by x minus 2. And if you do that, well, ultimately, luckily, you might notice that this was the exact algebra division that we did on the previous slide. And we found out on that previous slide that the quotient was this, and the remainder was this. Now, the remainder being 0 is not a surprise. If you're getting a remainder of 0, that is exactly what should be happening if something is a factor. Now that's useful because if you already knew it was a factor, we're starting to do the algebra division, but we already know what we're expecting the remainder to be. So it's a way of checking your answer sometimes. If I didn't get a remainder of 0 after being told that something was a factor, then I know I've made a silly mistake potentially. So that's something to be aware of. However, we've got the quotient, we've got the remainder. What to do with that? Well, the quotient is telling you one of the things that the original expression we had factorized into. So it's telling us that 2x cubed minus 9x squared plus 13x minus 6 factorizes to the x minus 2, because that was one of the factors we've given that in the question. But the other factor is the quotient we're given. Because we had a remainder of 0, the quotient then is just the other factor. So this is how I can then factorize that cubic. However, we're not done. If the question asks us to fully factorize something, you then have to use the fact you've already managed to break the cubic down into a linear factor and a quadratic factor to then see if you can factorize it even more than that. Sometimes you'll be unable to, but sometimes you will. In this case, for instance, you're able to factorize 2x squared minus 5x plus 3 into even more factors by factorizing that quadratic. That would get you, for instance, in this case, x minus 1 and 2x minus 3. So there you go. This would then be the cubic fully factorized, splitting into all the possible factors we possibly can. So here we go. That's one example of how algebra division might appear as part of a question. And here is another example of how algebra division can be useful to do things. For instance, we've got this fraction. Now this question says rewrite. You're not really going to have a question that says rewrite either in that vague way. I'll show you another way later on this video how they might say that more specifically. But also sometimes you just want to rewrite. So that's kind of why I've said the word rewrite, because sometimes it's a good idea to rewrite a fraction. Now, ultimately, the fact we've got a fraction is already giving a big clue that we want to do algebra division, because a fraction literally means divide. So therefore, we could do the top divided by the bottom using algebra division. And if we were to do that, well, conveniently, this is also one of the examples we did earlier. So we already know the result. So therefore, we've got the quotient this time of x plus 1 that we got earlier, and also we found out earlier the remainder was 3. How do we use those facts? Well, here is what you've got to do. Here's what you've got to realize. If you're doing a function divided by another function, the way you can then rewrite that is you can write it as the quotient, whatever you get for the quotient, plus whatever you get as the remainder divided by the original denominator of your fraction. So with this structure, this allows you to be able to rewrite an algebra fraction. So with that said, for our algebra fraction, we know the quotient is x plus 1, so therefore we're just going to write an x plus 1 just nicely by itself. And then with the remainder, we're going to write that remainder as the numerator for a fraction that has a denominator that's the same as the original denominator we had in the original fraction. So there you go, we're able to rewrite this fraction in the following format that I've shown. One final example we're going to do to put it all together, and this shows the more posh way they might write what we were looking at on the previous screen. So given us an algebra fraction, and then basically told us it can be rewritten and what format it can be rewritten in, and we've got to find the effective value of the a, b, and c, and the d to help us do that rewriting. How are you going to do it? Well, it is just algebra division. However, one little last thing I want to point out, and which is the reason I'm doing this example, is there are a few little details you sometimes have to watch out for. For instance, you notice that in polynomials, basic expressions that look like this with x's to various powers, often we have almost every power of x in those polynomials. However, not always. For instance, this polynomial is missing an x to the power of 1 term. Now, to make your life easier with this method, it's a very good idea if you leave a gap to account for the fact that there normally is x to the power of 1 or just x term involved. And so you need to leave a space to allow yourself the room for those bits to appear, because a lot of this method is easier when everything's sort of lining up in the certain powers, because then it makes the sort of taking away stage of it a lot easier to do. So you can either leave a gap, so I've left a gap, then write a -4 to leave that gap for the x power 1. Some people even like to write in something weird like this. They'll write a plus 0x in there. Now that's a bit weird because of course, you know, it doesn't make sense to write 0x. It's not wrong technically, but 0 times by x is obviously just 0, and we don't write 0 if there's a 0 involved a lot of the time. But you're welcome to write that down if it helps remind you to leave the gap, and also, you know, ensure that you've got this nice sort of column aspect to the method being maintained. Anyway, we're then dividing by x squared minus 5x plus 6. That looks a bit more complicated. Again, people might be going, oh my god, how do I deal with that? Well, it's not really any different from before. You look at the highest power thing over here, highest power thing there, divide them. So minus 7x cubed divided by x squared is minus 7x. Minus 7x times by the entire quadratic would be minus 7x cubed, a plus 35x squared, and a minus 42x. And then you've got to subtract all of that from the row above. So the 7x cubes will cancel out. We've got 2x cubed minus 2x squared minus 35x squared, which is minus 33x squared. We've got 0 minus 42x, which is a positive 42x. And we've got the minus 4. Highest power thing here, divided by highest power thing over there. Minus 33x squared divided by x squared is minus 33. So then minus 33 times by the entire quadratic will get us minus 33x squared. Minus 33 times by minus 5x will get us a positive 165x. And then we've got the 6 times the 33, so minus 33, sorry, so that would be minus 198. Wow, big numbers. And then we're going to subtract all that away. So the 33x squareds will cancel out. 42 minus 165 will get you minus 123x, and then minus 4 minus 198 will get us positive 194. Now, I'm done at this stage. Again, looks weird because now this time we've got more stuff in the remainder. The remainder is not just a number. That's fine. The remainder can still have algebra in. We know we're done, not by what we see in the remainder. The reason you know you're done is because you again look at the quotient and realize you'd reached the point where you had a constant in the quotient. So that's what told me I was done, even though the remainder still looked quite complicated. And what that tells me is, therefore, our original algebra fraction, which was this, can therefore be rewritten as our quotient, which was minus 7x minus 33, plus our entire remainder, minus 123x plus 194, all divided by the original denominator that the original fraction had. There you go. So that's how we can use algebra division in a more complicated scenario as well. Okay, that is algebra division for you. As I said, there's an alternative method. Do watch the video on that if you're interested to see an alternative way of setting this stuff out. You don't need to know both methods, but there might be one or the other out of the two methods that you prefer doing. So there you go. I'll see you in a future video. Goodbye.